This lesson is on radical equations. We're going to be solving equations that involve radicals, so square roots, fourth roots, etc. First, we're going to go over the steps and do a quick example. Your first step is going to be to isolate the radical on one side of the equation, so you're going to get rid of everything except for what's under the radical. The second step is to raise each side of the equation to the power of the index. So if the radical has an index of 4, you're going to raise it to the 4th power, and that will help get rid of the radical. The third step is to solve the remaining equation either by standard solving or sometimes you'll have to factor. And the fourth step is to check for extraneous solutions, and that means that you're plugging your answer back into the original equation. If the solution doesn't work in the original equation, that means that it's extraneous. So let's look at example 1. Our first step is to isolate the radical, so we need to get rid of that 5. So I get the square root of x equals 7. Well, to get rid of that radical, my index is 2, so I'm going to raise everything to the 2nd power, and I get x is 49. Now, to make sure that that's not an extraneous solution, I'm going to plug it back in for x in the original equation. So we know the square root of 49 is 7. 7 plus 5 is 12, and 12 equals 12, so I know that that solution works. All right, looking at example 2, I need to isolate the radical, so I'm going to subtract this 3. So I have the negative 4th root of m equals negative 3. I'm going to divide by negative 1 because I want to get rid of that coefficient. I have to isolate the radical. I have the 4th root of m equals 3. And then I'm going to raise everything to the 4th power because the index of that radical is 4. So I'm left with m equals 81. Now when I go back in and check my work, I'll have 3 minus the 4th root of 81 equals 0. So 3 minus the 4th root of 81 is 3. So 3 minus 3 equals 0. And that equals 0. And if you didn't know off the top of your head that the 4th root of 81 was 3, you can always do a prime factorization, and that will get you to that answer. Now I want you to try number 3 on your own, and then we'll go over it. So looking at number 3, I need to subtract 10 from both sides, and I get the square root of a plus 7 equals 1. I'm going to square both sides. So I get a plus 7 equals 1. Subtract 7, and a equals negative 6. When I go back in to make sure it's not extraneous, I'm going to have 10 plus the square root of negative 6 plus 7 equals 11. Well, that's 10 plus the square root of 1, which is 10 plus 1. And 11 equals 11, so that's good. All right, looking at example number 5, it's a little bit different because I don't have a radical. But I'm still going to do the same steps, so I can divide everything by negative 9 to get rid of that coefficient. And I end up with 4 equals c minus 12 to the 1/2. Well, if I do that, that's the same thing. Or I can get rid of that 1/2 exponent by squaring it, because c minus 12 to the 1/2 is just the square root of c minus 12. So I'm going to square everything, and I get 16 equals c minus 12. I'm going to add 12 to both sides, so c equals 28. Now, another way I could have done that is saying, okay, 4 equals c minus 12 to the 1/2. That's the same thing as 4 equals the square root of c minus 12. And I still would have squared both sides. Now I just need to make sure that my solution will work. So I get negative 36 equals negative 9 times 28 minus 12 to the 1/2. And that's negative 36 equals negative 9 times 16 to the 1/2. which is negative 36, equals negative 9 times 4, which works. Now I want you to try example number 6, and then we'll go over it. Looking at example number 6, the first thing I'm going to do is get rid of this 11. So I've got 7p minus 1 to the 1/3 equals negative 4. Or I can write this as the cube root of 7p minus 1 equals negative 4. I'm going to cube both sides. So 7p minus 1 equals negative 64. Add that 1 to both sides, and 7p equals negative 63. Divide by 7, and p equals negative 9. And when I go back through and check my work by plugging it in as 7 times negative 9 minus 1 raised to the 1/3 plus 11 equals 7, it works out. Now looking at example number 9, we have radicals on both sides, and all I'm going to do there is raise it to the exponent on both sides. So this becomes u minus 8, and this becomes 43 minus 2u, and I can solve it like a regular equation. So I'm going to subtract u from both sides, or add 2u, excuse me. So 3u minus 8 equals 43. Add 8 to both sides. And divide by 3. And when I plug that back into my equation, it works, so I know that that answer is not extraneous. Now I want you to try number 10 and see how it goes. Looking at number 10, that radical has an index of 4, so we're going to raise everything to the 4th power. So 27 minus 2d equals d minus 3. 27 equals 3d minus 3. 30 equals 3d. And d equals 10. And when I plug it back in for 10, that should have been a real solution, not an extraneous solution. Looking at example number 11, I have coefficients, and the first thing I'm going to do is try and isolate my radicals. So I'm going to divide by 4 on both sides. So on this side, I'm left with the square root of 3q plus 15. Now on this side, I'm left with a number, and that's okay. I'm still going to follow my steps of raising it to the power of the index. So this will leave me with 3q plus 15. Now on this side, that 2 gets distributed to everything. So 3 squared is 9, and the square root of q squared is just q. So I get 15 equals 6q. So q equals 2.5. Now I want you to try example 12 on your own. Now the only difference with example 14 and 15 is that there are more variables, but everything is going to be the same. So I'm still isolating that variable, or that radical, and I'm still squaring on both sides. So I'll have 12 minus a equals a squared. And I'm going to get everything on one side of the equation so that this is kind of like a quadratic. So I'll add a, and I'll subtract 12. So 0 equals a squared plus a minus 12. And I'll factor it to solve. So that'll be a plus 4 and a minus 3. So a can either equal negative 4 or a can equal positive 3. Now what I have to do is plug both of those solutions back in to make sure that one of them isn't extraneous. So I'll start out with plugging in the negative 4. So the square root of 12 minus negative 4 plus 7 times negative 4 equals 8 times negative 4. So if I keep change, That would be the square root of 16, which is just going to be 4 plus negative 28 equals negative 32. Well, this is actually negative 24. So that one won't work. So 4 is extraneous, which means it's not a solution. However, when I plug in the number 3, it does work, so that will be the solution. I want you to try number 15 on your own. Looking at example 17, I'm going to carry through the same way as I normally would, only my radical is already isolated, so I'm going to square it. So 51 minus 5y equals y squared minus 22y plus 121. And now I'm going to solve this like a regular equation. So add 5y and subtract 51. So I get y squared minus 17y equal or plus 70. And that's going to be y minus 7, y minus 10. So y can either equal positive 7 or y can equal positive 10. Now when I plug those back in, neither one of them work. They're both extraneous, which means there is no solution. And I want you to try example 18 on your own.